All right, so this is a continuation video to the earlier recording for exploitme001 C program. All right, so in the earlier recording, I've shown you how you can actually manually calculate the number of bytes you need, right? The number of bytes you need to overwrite from the start of the local variable all the way to the return address, right? So I taught you how to manually calculate this difference, all right, to derive on the number of bytes you need. All right, so that is the first video actually shows you the manual method. All right, so if you look at the buffer overflow solution.doc, right, which I've uploaded this lab solution that I've uploaded into Teams channel. All right, you can actually look at page 19. Page 19 actually consists of an alternative method that you can actually use. I'll just quickly show you how to do it. All right, so I'll be using the same exploitme code. I'll just put it into GDB. Right, exploitme001. All right, put it into GDB. So if you look at page 19 of the solution, it actually consists of a step, right? So you can actually leverage Metasploit to help you out with this. All right, so if you go to Metasploit, Framework, Tools, Exploit. All right, so you can actually create a pattern. All right, so you can pattern create .rb-l. All right, so you can put in, for example, 288 bytes. So what this command does is that it will actually generate a pattern, all right, a unique pattern that is of 288 bytes. All right, so it's unique. All right, so over here back to our GDB, you want to set a breakpoint again, right? Disassemble main, and I would want to set my breakpoint somewhere after string copy, right? So I'll break somewhere here. Right. Okay, then I'll run my program. So how do I run my program? I'll run it by printing characters to it, by feeding characters into the program. So what do I want to feed? What user input do I want to feed in into the program? So what I want to feed in is pretty straightforward. I'll print. So basically what you want to feed it, the string that you want to feed into the program is the random patterns. Oops, random patterns that you have generated using Metasploit. All right, just copy this, put it in. You run your program, you stop at the breakpoint. All right, so you will need to continue with your program using next instruction until it crashes. All right, so it crashes at this specific location. All right, so if we look at the EIP, all right, so what is currently EIP is basically the return address. If we look at the return address, what is returned to the address? Return address is this specific string. All right, so if we use Metasploit again, if we copy this I9AJ, right, and we use the pattern offset command, -q, right, so we put in the string that is being returned from the EIP. And you put in -l, the number of bytes that we used to generate the pattern earlier, right? So that would be 288 bytes. All right, so it will tell you that the offset is 268 bytes, right? So 268 bytes essentially is the start of the buffer location all the way until the end of the safe frame pointer. All right, 268 bytes. All right, so if you want to include the return address, you will need 268 bytes plus 4, which is 272 bytes. All right, so this is the same, this is an alternative technique to what I have already explained in the first video. All right, so I hope this helps. Go through both the videos, and I'm pretty certain that you guys and girls will not have problem with the practical test if this sort of question comes up. All right, thank you.